2x to the fourth plus 4x to the third minus x squared plus 9. I'm going to ask you to solve for all the zeros. That's where we're going. And so there aren't a lot of factor patterns that are going to work for you. Okay? We're going to learn a whole bunch of tricks. But brute force is one of the things we're going to have to deal with. We're going to have to deal with that occasionally. What we're going to do on this is we are going to literally take one of these factors and guess and plunk it in there. Now notice how much work that is per problem.
Yeah, look at that.
It might be a good idea. It might be a good idea to check to see if the answer works first before you go to all the trouble of dividing it. Does that make sense? So if you look at problem number one says we're going to guess x plus 1, this is on the back, is a factor. I'm going to guess that x plus 1 is a factor. I'm going to try to see if I can guess it's a factor. Now, before I go through the fun that is that left-hand board there, right? Before I go through doing a long division problem to prove it's a factor or not. By the way, it's a factor. What would my remainder be? 0, right? Because I'm dividing by an even amount. That's how you get a factor, right? So if I got a remainder of 0, that would be a factor. If I don't get a remainder of 0, that means I guessed wrong, try again. I don't want to do that. But what does it mean if it is a 0? Chris, R? If this is a factor, that means that x equals -1 would do what to this function? Make it equal 0, right? So before I try to divide that out and do it longhand and see if I can get a remainder of 0, we're going to do something called the remainder theorem, which is this. Plug in the -1 over here and see if I get a 0. If I don't get a 0, then there's no point in trying to divide this, right? I'm wasting time. Guess another choice. Does that make sense? Okay, so I'm going to go ahead and plug a -1 in here. Now notice I didn't plug in +1, I plugged in -1, right? What makes it a 0? Right? So I would get 2 minus 4 plus 1 plus 9. Is that agreed?
Why do you get +1?
I don't. I get -1. Thank you.
Okay.
All right.
But it doesn't work either way.
So I solve this and I get 11 minus 5, I get 6. So should I bother to divide by x plus 1 because it might be a factor?
Yes.
Answer, no. It's not a factor. We know it's not a factor. It didn't make the whole thing go to 0. There's no chance it's a factor. Don't waste your time. Is this quicker than actually doing the division? Okay. Yes. This is called the remainder theorem. The remainder theorem is plug in what makes this a 0 into the function. If it makes it a 0, then this is a factor. If it makes it any other number, then this is not a factor. Now, one little strange caveat. If you did the division, this would actually be the remainder. Okay? I'm going to do that on the right-hand board over here. I'm going to go ahead and do the long division version. You don't need to do that. Instead, what I want you to do is try number 6. Okay? Try number 6. And the question is, determine whether the binomial is a factor or not. Not do the long division. Determine whether it's a factor or not. We try the other one. We've got 6. We've got 2x to the third minus 3x squared minus 10x plus 3 divided by x minus 3. Is this a factor or not? Answer.
No.
Put a 3 in here.
Yes.
2, 3 to the cubed. 3 squared minus 10 times 3 plus 3. So I get 27 times 2, that's 54. Minus 27 minus 30 plus 3. I get that 0. That's a factor. That make sense? All right, so I'd write yes. That's worthy of checking. All right. Try 7 through 12.
Wait, negative 2 to the power of 2 is negative 4.